So looking at this review, the first thing we notice on this question is that we need to make the units agree because it wants to know about the constant acceleration required to increase the speed from 35 miles per hour to 50 miles per hour in 5 seconds. So it says that we started off this fast. That means at 0 seconds we were 30 miles per hour, which is 30 times 1 mile divided by 1 hour. But 1 mile is 5,280 feet. 1 hour is 3,600 seconds. So that means at time 0, we were going 44 feet per second. Then after 5 seconds, we were going 50 miles per hour, which is 50 times 1 mile divided by 1 hour. 1 mile is 5,280 feet. 1 hour is 3,600 seconds. So that's 220 divided by 3 feet per second. So if acceleration is constant, then that's the k that we need. When we take one antiderivative, we get velocity as kt plus c. So now c is what I want, but we know that c is just the initial velocity of 44 feet per second. So we get that velocity is kt plus 44. So then when we plug in 5 seconds, we must get this out. That means we get this out when we plug 5 in here, and we solve for k, which is 5.87 feet per second squared. Okay, if I want to find the upper and lower approximations for this thing, here I'm just going to do one of the two. So here it says to find the upper and the lower. So if I find this one, I'm finding the upper. So to find the upper version of this, I'm going to look at each one of my rectangles. And on the first, I'm going to plug in the right-hand endpoint. I'm going to find the lower first. So since it's a decreasing function, the right-hand endpoint gives a lower approximation. One way to see that is, here's an interval, and it's below the curve. Here's an interval, it's below the curve, etc., etc. So for the right-hand endpoint on the first interval, I would have this. For the right-hand endpoint on this second interval, I would have this, and etc., etc. So you're just going to get 2 times all of these height at the right-hand endpoints. So you're going to get this, and it's going to work out nicely. So I'll let you finish the rest of that. Here, this is a graph of the velocity of a rocket as given below. Use upper and lower estimates to find the total distance in the first 60 seconds. So 60 seconds goes to here, and they're wanting to use 3 rectangles. So let me first find the upper estimate, and then I'll let you find the lower. So if I use 3 rectangles, this is time, and this is velocity, which is a function of time. So my delta t is equal to b minus a over n. Well, 60 is my b, and a is 0. So 60 minus 0 over 3 means I'm going to take a step size of size 20. So here's the first one, here's the second one, there's the third one, there's our 1, 2, 3 intervals. So for my upper approximation, I'm going to have a velocity at some point t1 inside the first interval times my delta t. There's my first rectangle. Plus velocity evaluated at t sub 2, some point in my second interval, times the width of the rectangle. Plus v of t sub 3 times my delta t. But in this case, my t1 is just the right-hand endpoint because I'm wanting an upper approximation. I'm going to plug in 20. V sub t, we said was 20, plus v of, in the second interval, it looks like 40 is my right-hand endpoint, right? And times my 20 width, plus v at, looks like v at 60 times my 20, that's going to give me this. So it looks like the height of the third v of 60 is pretty clearly 5,000. It it looks like the height of 40 is pretty clearly 2,000. Thank you for picking ones that worked out nicely. And then the last one, it's pretty close. It's almost up to 1,000. I'd say it's about 800. And again, it's approximation. 800 times 20. So this is going to be 16 with 1, 2, 3 zeros. This is going to be 4 with 1, 2, 3, 4 zeros. It's going to be 10 with 1, 2, 3, 4 zeros. So 100,000, 40,000, and 16,000 is about 156,000 what? Feet? It's going to be my total distance. Does that make sense if I'm going a velocity? Oh yeah, I mean if my velocity is like 1,000 feet per second, yeah, it makes sense that I go 156,000 feet approximately in that time. Cool, approximately. Cool, all right. I'll leave you to find the lower estimate. In this case, that would be using the left-hand interval, left-hand endpoints, because it's an increasing function. Here, this written in interval notation, well, it's going to be an integral from 1 to 3 because they give me the bounds of integration. Then everywhere where you see an x sub I, that's just a sampling point inside of your function. So if it's x sub I divided by x sub I squared plus 4, then your function is x over x squared plus 4, and your delta x turns into dx in the limit. So that would be your answer. For number 11, if we see this function, this x to the fifth, gets pulled up top so that we can use our power rule. And then the antiderivative of this is that over 2. The antiderivative of this is add 1 over that same number, and then you just clean it up like so, where this goes down to the bottom as a positive. 2 cancels out here, makes it -6. We go to town. Look at number 12. So here it's already written in a nice power form. So if we add 1 to -1/2, we get a +1/2 over the same number. If we add 1 to this, that's like adding 5/5. So we get this over this with, let's see, with this over this. This should be a negative still. I don't know why I turned it into positive. So it should be that over that. Is that correct? So it's going to be add 1 over the same. Then that's going to have an x. So that means that that's going to be that, and that's going to be that. Cool. Don't forget your plus c. I would see that as a problem that's going to come up a lot for kids if they're not careful. Here, again, it's already in the power format. So if I add 1 to -3, I get -2 over -2. I pull out the constant. If I add 1 to 1/4, I get 5/4 over 5/4. Pull out the constant 8, and then add 1 over that same number. When you invert and multiply, you get this. When you take this and put it in the bottom, you get this. And don't forget your plus c. All right, then moving on to 14. So when you're looking at 14, this is -3/4. Add 1, that would be adding 4/4. When you add 4/4, you get 1/4 over that same number. When you add 3/3, you get 4/3 over that same number. When you add 1/2, when you add 1, you get +1/2 over that. And then you just invert and multiply. Invert and multiply. Invert and multiply. For 15, we would distribute this out to get this, and then just take the antiderivative. Ooh, look at me being tired when I did this. So be careful, that's to the 5th over 5, right? 5th over 5, that's 2 over 2, okay, right? Let's look at 16. So first thing you would do is multiply this by itself to get 4y squared, and a y to the 4th. Then taking the antiderivative, that becomes that. This becomes this. And this, man, why did I keep on doing that? Is 2 the 5th over 5. Just had 4th on the brain that day. 17, again, you cannot distribute this in because only linear functions do that. You actually have to multiply this out here and then distribute this in. So multiplying this out, we get 4 minus 4 plus x squared. Distributing this in, we get this, that, and if this is 6 halves, no, we want the same as 2. Yeah, so that's 6 halves. No, only in thirds. So yes, it'll be 6 thirds. Add 1 is 7 thirds. Right, so then you add 1 over the same number, add 1 over the same number, add 1 over the same number, and then invert and multiply. Make sure all my signs are right, and don't forget your plus c. As soon as you take the antiderivative, that's when you drop these symbols and add the plus c. So I should see these symbols go away as soon as you take the antiderivative. That's also when I should see the plus c pop out. 18. You got to multiply this sucker out. When you do, you should get 2. You should get 2 negative x plus 2x squared minus x cubed. That's the antiderivative. So is that. So is that. So is that. Don't forget your plus c. Again, notice as soon as I take the antiderivative, those go away and the plus c pops out. 19. If I have all of these added together over the common denominator, I can break each one of them up. That over that for 19. That over that should give me x to the first. So be careful there, boop. That over that should give me x to the first. Let me clear up that. So x to the fifth over x to the fourth should give me x to the first. Take the antiderivative, you get x squared over 2. The second one should give me x to the negative second. That's correct. Next one should give me negative. Yep. So that's x squared over 2. So there's 19. Let's see, for 20, again, same deal. If I have 2 subtracted over a common denominator, I could break it up into this over that, which is t to the negative third, and this over that, which is negative 2. So that, which gives me that. Notice again, as soon as we take the antiderivative, these two disappear, and the plus c gets added. For 21, we're now getting the trig ones. If I have this, first the integral of a difference is the difference of two integrals, and you can pull out the constants. So then the antiderivative sign is negative cosine. The antiderivative of secant squared is tangent squared. Don't forget your plus c. 22. Cosecant squared. When you're looking at this one, the integral of a difference is the difference of two separate integrals, these two. And I know the derivative of cotangent is negative cosecant squared. So this antiderivative must have a negative. Well, there's already a negative out here. So what is the antiderivative of secant tangent? It's just secant plus c. 23. Well, first I would distribute here to get this. And then the antiderivative of tangent is secant squared. And the antiderivative of secant is secant tangent. 24. Again, same sort of deal. Distribute these out. We distribute these out and we get this. Then cosecant is 1 over sine. So this becomes 1. And the last one is cosecant cotangent. So the antiderivative of 1 is x. The antiderivative of cosecant cotangent is negative cosecant x. Don't forget your plus c. 25 is secant over cosine. But this is just 1 over cosine. So that means this turns into 1 over cosine squared, which is secant squared, whose antiderivative is tangent. Notice, as soon as you take the antiderivative, these go away and you get your plus c. 26, this looks weird, so I'm going to rewrite it as 1 over cosecant of y times dy. This just looks weird, dy over stuff. So I'll pull it out here. Now it looks right, but 1 over cosecant is just sine. So the antiderivative is negative cosine y plus c. 27, if you have this, you can break it up into 1 over cosine times sine over cosine. But 1 over cosine is secant, sine over cosine is tangent, so the antiderivative of secant tangent is just secant. Don't forget your plus c. 28, this is phi, so 2 over sine squared phi is just 2 cosecant phi. So if you derive phi, you get phi squared over 2. And then what do you take the derivative of to get cosecant? Well, that would be negative cotangent of phi. All right, 29 is this. We're going to rewrite cosecant as 1 over sine. When you do these cancel out, and it gives you this. And so the antiderivative of 1 is theta, and of sine is negative cosine. 30, if you got this, if you got two things added together over a common denominator, you're going to break it up into the first one divided by the denominator plus the second one divided by the denominator. But cosine, 1 over cosine is just secant. So this is really secant squared with a 1/2 out front. And cosine over cosine cancel out and just give you a half. So the antiderivative of a half is half x. And the antiderivative of secant squared is tangent. So the antiderivative of this is that. Okay. 31, one way, the hint was to change the form. Well, guess what? If you multiply it by this well-chosen 1, you end up getting this. Why might you do that? Because we know that we often like to multiply by that conjugate on the top and bottom. And because the bottom ends up being cosine squared, but then a difference of two things over a common denominator is the first one over the denominator minus the second numerator over the denominator. So this is just secant squared, and this we break up into a similar way that we did before. 1 over a cosine with the other cosine being underneath a sine. So it's really the antiderivative of secant squared minus secant tangent. But the antiderivative of secant squared is tangent, and the antiderivative of secant tangent is secant. This one is definitely optional. So I'm going to show this here, and you'll see it in the key, but I'm not going to explain it. So have fun looking at that, because I don't want you to freak out about that for the test. But for 39, if you have a second derivative is equal to this, if we take one antiderivative, we get this function. So we get a plus c, right? Then cleaning it up, we get this. But then we need to apply our initial condition. And we get that the output of 12 must happen when you plug in 0 everywhere. So that means that c is equal to 12. And so this is now what we get for the first derivative. Well, then we take an antiderivative. We take one antiderivative. So this is an antiderivative. Take one antiderivative, we get back here, which is just this. But then if we apply our other initial condition, we get that c is equal to 4, and that is our function f. Then for 21, we know that the integral of a sum, 21, the integral of sum is the sum of the integrals. And so, be careful with that. The integral of sum is sum of the integrals. And so, this should actually be a plus. And when we pull out the 2, so we take the integral of f plus the integral of 2 gx. Then we can pull out this 2, and that's why it looks like this. But then they give us, that this is equal to 5 here, and that this is equal to -3 here. So we actually end up getting, if you'll let me put this right here, it's -6 plus 5, which is -1. -1. Then 22, the integral of a difference is the difference of two integrals, and you can pull out the constants. That's how we get this. But then we know that this is 2 because that's what they gave us. And we know that all of this is 10, which is what they gave us. So we get negative 4. For 23, the integral from 1 to 5, well, we know from 0 to 1 it's negative 2. And 0 to 5 it's 1. So what they want, 1 to 5, is just the integral from 0 to 5 minus the integral from 0 to 1. So this turns out to be 0 to 5 is 1, and from 0 to 1 is negative 2, so we get an area of 3. Well, 24, they want to know from 3 to negative 2. Well, those bounds are backwards, so I flip the bounds of integration to put the 3 up here and the negative 2 down here. As soon as I do that, a negative pops out. So I get negative. Well, it turns out that this is just the area from negative 2 to 1 and then 1 to 3. Well, from negative 2 to 1 is 2. From 1 to 3 is negative 6. So we get negative 4, make it negative, gives me a positive 4. Finding the area from negative 5 to 1. That's just a circle of radius 2, but we have half of it. So I need to know that the area of a circle is pi r squared. I will not give you that on an exam. So that's that. Here we break up the area from 0 to 3 as being a triangle plus a rectangle plus a triangle. Well, this is 1/2 times 1 times 2 because it's always the area of a triangle is always 1/2 base times height. And again, I assume you know that. So when we add all those together, we get negative 4. Here, they want this. If I pull out the constant, it's really negative 5 times the area under the curve from 3 to 6. From 3 to 6, it's negative 6. So negative 5 times negative 6 is 30. Here, they want the integral of sum when we know that that's the sum of the integrals. And the area under the curve from 0 to 5 is 4. And the area of h from 0 to 5 is negative 8. Add them up, you get negative 4. Here, it wants us to know from negative 8 to 2 and from 0 to 2. Well, that's really negative 8 to 0. And so from negative 8 to 0, it's just 5 minus 6, which is negative 1. And that's it. Happy studying. Come in tomorrow morning if you have any questions. And by tomorrow morning, I mean Monday. What is today? Monday, March 24th, if you have any questions.